We did this lab yesterday. We created a VPC. We created two subnets. One is to launch a EC2 instance inside, launch a VM virtual machine inside the subnets and connect from PuTTY. So for that, we need to create an IGW internet gateway and also write some routes to pass our request from IGW to our subnets or the resources in the backend. So before doing that, we first create an EC2 instance and check whether we can directly connect to that without these settings. Go to our AWS. You can go to the services in our AWS and go to compute and then select EC2. Then you can go for launch instance and launch an instance. Select the AMI, so Amazon machine image. Uh, so Amazon machine image. Um, AMI is the images. Generally, whenever we install any server, we will take an image and then launch instance of it, similar to our laptop. So whenever we have a fresh laptop, we will take an image like Windows image or ISO image, and then boot that image into our server, similar to that. So we will take an image here and launch the server with that image. So let's do that. I will select Amazon Linux. It is easy and free. I will select T2 micro at this time. Review and launch. So here are the few details we need to check. So I choose an AMI and instance type. I choose T2 micro configuration items. These are the details of our instance. So our aim is to launch instance here where we created um, our subnets and VPC. So our our network, our VPC is dev VPC, and our net is we have two subnets. Remember, subnet 1 and subnet 2. We can create our VM in any of the subnets. I will select VM 1A. So after I send public IP, as I said, public IP is the IP which is accessible through the internet directly. So at this point, we will select this because we need to connect from PuTTY via internet, right? So we will select this so that our VM will get we will get a public IP, right? So these are placement groups in the sense. So uh, if you are um, choosing our VM to launch in a particular disk. So for example, what I can say, like, here is the so here we have a rack in AWS data. So we will have different racks in the data center, similar to our on-prem data center. So we will have racks here. So every rack will have some here. So these are the racks, individual racks. So, and if you choose to create your VMs, all the VMs in particular data center in a particular rack, so that is called uh, that is called that is called placement group. So you want all your dev servers in one rack and um, all your productions in one rack, so that they can communicate with each other very quickly. So this is my dev rack. This is my prod. So similar like this. So you can divide in terms of racks. So but before that you need to make sure the space is available in this particular racks. Um, because AWS by default will distribute our VMs all around the racks, because if you are not given specifically, because there may be some space issues for Amazon. So if you decided to keep all the servers in one particular rack, then you have to buy a reserved instances for that. I guess. So once you buy the reserved instances, you will be able to get all your instances in a particular rack. So that is placement groups. So you can add a placement group like this. So uh, but it again depends upon the requirement. And capacity reservation, I'm not sure about this one. Target by group, target, I don't know this one. Domain, join directory. We don't have any domains right now. We can leave the IAM role. So we can also attach the role once we create the VM. So we can talk about this later. IAM role is like, so when you have your application connected to different integration services, like your application need to connect to database, or application need to connect to MQ server, your application need to connect to mainframe server. All this comes under these roles. So using these roles, you can your VM virtual machine can talk to those integrated servers. Shutdown behavior, we leave this as default. So we have to terminate and stop. Stop is like whenever you shut down, it will just stop. If you select this as terminated, whenever you stop your instance, it will be deleting from the Amazon itself. So yeah, there is no disk, even the disk will be erased. Okay. Stop hibernate behavior. I don't know this one. Enable termination protection. When you enable this termination protection, so your VM cannot be deleted unless you uncheck this manually. So that's it. So for example, whenever you got a fresher in your team, so if we try to terminate the VM repeatedly, so it will not allow directly to terminate the process. So first, initially, he need to whoever has the permission to term uncheck this termination protection, then only. So he need to uncheck this one and then go for termination. Monitoring, we can talk more about it later. CloudWatch. Um, Again, tenancy. Tenancy is like, if you want a mm, dedicated instances, and the dedicated instance, like if you want only in uh, particular instance type. We have different instance types. We can talk about them. uh, this is that one, if you want only that particular instances for you. So this is shared hard drive instances. As I said, this is similar to what I said earlier. So if you want a particular space in Amazon data center, they will provide, and your instance will created only in particular space. Uh, that is not required as of now. Really shared. So credit specifications, you can manage your credits, how much money, how much they can charge you on this particular instance. You can select a lower limit and upper limit. File system, as of now, we don't have to attach any other file systems except for the default. Hmm. Network interface, you can add a device network interface here. You will get an IP assigned to this particular instances. For suppose we uh, we connect our EC2 instance to the database, and we can and sorry, that is not one. So IP address, so whenever your load balancer is configured with your VM, so in the app server, for suppose, so it talk through an IP address. So, but whenever we log in, for suppose we are logging into the same machine, through the same IP, but of course to a different port. But even though the traffic, if you want to manage the traffic, whoever logins into the system, you should use another IP. Uh, so otherwise, the device which is talking to your application can use another IP. So you can attach in your interface, you can attach an IP here. So two IPs will be attached to your VM, right? So advanced settings, so these advanced settings are for your after VM is booted. So here metadata version, these are all details itself, so we don't have to go in depth. This will be managed by Amazon. User data, so this is something we can give as an input in the boot. So whenever you write some shell scripting here, it will be executed during the booting of your VM. That then go to the storage. Storage, as of now, as I said, we will use only default storage, EBS volume, which they called. So we'll talk about volumes later on. So this EBS volume, elastic block storage, um, is attached for your booting of the systems. So only EBS volume can act as a booting storage. Otherwise, no other storage in Amazon can boot VM machines except EBS. That's it. So you can increase the size, but you don't want to increase as of now. Add tags, you can add names to your VM. So let's say a name. Let's say this is my app server. You can just name that and go to the next one, security groups. So security groups are like firewall settings here. So like which port we need to open from which IPs and etc. So as of now, by default, we are opening only port 22 for us to log in. TCP transit control protocol, we can use port 22 to log in from PuTTY. So as of now, we are opening only one port. Uh, that's it. Review. So my review is done. I've launched the instance. Here, most important thing is setting a key pair. So create a new pair. If you don't have any key pair as of now, you can create a new pair, give a name, say my dev key, right? Dev key, download key pair. So my file is downloaded. It is still downloading, I guess. Okay, my PEM file is downloaded, right? Uh, then we can go for launch instance. Instances. So see here, instance state is pending. Still my instance is coming up. Let's wait till uh, it is active. So you can check these details of your VM here. We can select, they will be populated below. So what is your public IP address? These are the details you can manually create. So now before connecting to instance, we need the PPK file to connect from PuTTY. So where is my PuTTY? Oh, PuTTY will be here. So yeah, from PuTTY to connect to that particular instance. So for that, we need a host name. We will be getting that from AWS. But we need to have an PPK file for this. So to be loaded here. So that PPK file will be authenticated from your computer to the AWS. So we got a PEM file, remember? So we need to convert that PEM file to .ppk file for PuTTY to support that file. For that, we need a PuTTY Gen 2, so which is already there in my laptop. So I will go to downloads. see this is our key, and we will search for putty. So putty gem. Yeah, this is putty gem. Sorry, can open that too. Yeah, okay. You can load your PEM file. Downloads. DevOps dot. Sorry, not this one. Our dev dot key is our, uh, our file. PPK file here. Okay. Dev dot key. Okay. I loaded successfully imported. Okay. Then serve private. Yes. Without fast. Then give dev key. So it will be saved in PPK format. Dev key. I don't remember. Yeah, you generated a PPK file out of your PEM file. So now we come to that instance. Suppose here's my AWS. You can just, yeah, my instance is running and active now. So I can connect to my instance using a public IP, because remember we assigned a public IP to this instance so that we can able to connect from internet, right? So I will select now my documents, downloads, dev.k, key.k, go to machine, user IP, okay, then open. It will not open because your request, as I said, uh, your request is reaching, I don't know, it doesn't know where to go. So because we don't have an internet gateway attached to this VPC, right? So as of now, we don't have, yeah, our connection will be turned out. Just you okay. So now we need to connect to, we need to create a IGW to our VPC, then add some routes to our subnet. So this is one way, this is one way, and this is my one way, right? So our instance is here. We created an EC2 instance here, right? Right. So now I will create an IGW for this instance, this architecture. So we go to VPC, we need to attach that IGW and to our VPC, right? So now go to, again go to VPC, and see here internet gateway. So you click that internet gateway. Right. So we already have two internet gateways. Ignore. So we will create an internet gateway. So you can go my dev gateway, right? My dev gateway, and you can just create it. Yeah, this is just a naming convention. Create a gateway. So now we created a gateway, but we didn't attach that to the VPC. That is where this pop-up can attach to VPC. So we can attach to that to VPC, Otherwise, you can just ignore that one. Again, go to internet gateways and select your gateway. Where is my dev gateway? This is my dev gateway. Go to actions attached to VPC and select your VPC. Our VPC is a dev VPC. Remember, we can only attach one internet gateway to a VPC. We cannot attach more than one internet gateway to PC. Uh, so once we attach this VPC, we can directly select our VPC and attach to internet gateway. So our part is done. So our VPC is attached with an internet gateway, right? This is our VPC. Right, if you scroll it down, you can see the internet gateway. Somewhere it will be there. Now, you can go to the internet gateways and you can see attached to which VPC it is attached, right? So this is the default VPC which Amazon gives you. So if you created a VPC, it will be like this. So in our diagram, what we did is we created a VPC and VPC subnets, and we launched an EC2 in the one of the subnets, and we created an internet gateway and attached to our VPC. Till here, it is done. So whenever we request to connect to this EC2, or request will go to IGW Internet Gateway till our VPC, but it doesn't know which subnet or which resource it need to be connected. So for that, we need to add some routes, right? So once we add route, then only it will know the path through which it can connect to the resource. So for that, again go to the this one AWS, and we need to create a route table, right? So for example, whenever we create a VPC, by default a route table is created, which is by the name main. So here you can see there are three main route tables which are created by default, right? So generally you can delete these route tables um, after you create a new custom route table. For suppose I cannot delete my default route table which is attached to my VPC. So let's see what is the default with default what is see this is my route table which is created for my VPC. I cannot delete this one, right? See what I'm getting. See, cannot be deleted because this is a default route table, right? So remember, we get a default route table whenever we create a VPC. Now we ignore that one. We will create another route table. Create another route table. Name. My name. I will give dev route table. Right. And VPC. We can select our VPC. And you can add name as well. Tags. Just a name. Same thing. Dev route table. Right. And just stay wait. Close it. So our dev route table is create, right? One more thing here. So if you go to the default route table, um, see here, when you go to routes, I said we need to add routes after creating the route tables, if you remember. So we create a route table first, then we add a routes inside the route table. So let us check what are the default routes it has. So routes is like see here, this is, if you remember, this is our CIDR block for VPC. So what this is our CIDR block for VPC. So 10 dot this is a CIDR block which we use to create our VPC. 0 dot 0 dot 0 16. Okay, so this is our mask. So but when you see the route table, routes inside this route table, it says whenever the request is is originated from this particular IP, right? Okay, use local route to connect. That means whenever any instance or any resource uh, which is associated with this IP, which is in the VPC, or suppose this is our VM. So let's check what is the IP of this VM first. This is my VPC. I'll go C2 again to check our VM, our instances. So this is our app instances which you create. You should not check the public IP here. You should check the private IP. So this is our IP which is created for this particular VM, right? Also, so this is the IP. You can see here this IP is inside this VPC. Whenever a request originated from this particular VM, uh, what it says, what the route table says is use the local route, right? So whenever uh, a request originated from this IP, use the local route, and got it. So if this machine used to, let's say I created one more instance here. I have one more EC2 instance here. What it says, whenever this instance want to connect to this instance IP, so it says if requests are associated with this particular IP, so it is inside this VPC. So connect to internet route and connect to this instance. Simple, right? So whenever any instance, whenever a request originated within the VPC, connecting to the IP range of IP range within the VPC, it will use the local route. Okay, so request originate in here, and also the destination should also be here, right? Then only it will use the local route. See here, a destination. What here says the destination. Even the source should be on the same VPC, because if the source source is outside this VPC, then it will not use this VPC. It will not use this local route. Be more specific. So let's say I have another instance here. Uh, mm, this is also local route. So because two IPs can get the same IP in one VPC. Let's say another VPC. Let's say we have another VPC. This is another VPC. In this VPC, we are using another set of subnets. But whenever the instance in this VPC is to connect this particular subnet in this particular VPC, it cannot use the local route because it is outside this VPC. That's what I meant to say. So the request should originate from this VPC, and also the destination should be in this VPC. Then only it uses this route, right? That is a local route. That is why I said in the previous video. Where is it? Yeah, here I guess. So here what I said is the all the AW availability zones can talk by default, can establish um, can establish connection to each other, regardless of settings, because that is what they see. Our VPC is created in 1A and 1B, and we have a route that is local to this VPC. So whenever there are two instances here and here, they will be able to communicate without an issue, right? Even though they are in different availability zones, because they are in same VPC. But when there is an instance in another VPC, let's say here, okay, this instance cannot communicate with this instance directly. Okay, yeah, that's the point. And even though there is another instance with the same vendor, it should not be able to communicate, right? That's it enough for that one. Yeah. So this is my local route. So our all the instances in our VPC will be able to communicate with each other without any issue. That is what my point. So subnet associations, by default, you will don't have any subnet associations because all the subnets are by default associated. There will be no custom associations. If you create a new route, then you should add these subnets to your associations, right? These are edge associations. As of now, I don't know this one. Route programmation. These are like if you create a multiple IPs in to your resources, then you can use this one. Tags is just name. Um, so what we do, we delete this one. We will talk about subnet associations after deleting this one. So to delete this one, mm, so whenever a request originated, oh, again, not to say. So whenever a request originated in our VPC to connect another resource, to connect another resource which is in the same VPC, um, which is in another VPC. Let's say this is VPC. Whenever request originated to connect from this EC2 to this EC2, it uses a local route, as I said. But if you created a custom route table, by default, these two subnets are not associated with this route table, right? See, you can show that. So uh, let's say this is my default VPC default route table. If you go to associations, we have two association subnet associations, right? Um, you go to edit subnet associations, we can delete these associations. So as you said, current route table, main route table, this is default route table. So whatever the subnets inside the VPC, all will be added by default to this route table. But if you go to the custom route table which we created, if you go to subnet associations, we need to add these two subnets and say, otherwise they will not be part of this routing table, right? Okay. Simple. Whenever we didn't add anything in the subnet associations, it will use the default route table to route our request. But whenever we are creating a custom route table, we need to add the associations to in the route table to establish the communication, right? That's it. Okay, let's add this associations. I added associations here. Um, here, if you remove this, let's remove again. You can remove subnet associations and say, see, here we have a subnet we have a destination inside this VPC because we at that VPC initially we created a route table, but it is not attached to our VPC. Okay, right? We created a route table, but we didn't attach that to VPC. At that time, this particular line will not be there because the route table does not know which which CIDR block the VPC is. Right? Only once we attach that VPC to this particular route table, then only this line will be appeared. Okay. Uh, so even so, at this point of time, it will route locally, right? But it is not a main route table. Subnet associations, you can add the subnet associations again. Just want to see this, and I want to make my subnet. I mean, my route table as a default one. How can I do that? So we have to first make our route table as a default route table, right? Select your route table, I guess. Uh, Set my route table. You can select that one. Just click on OK. Then yours will be a default route table, and the default route table will be marked as no, which is a not default route table. So you can then only before I showed you we are not able to delete this route table. Now we'll be able to delete this default route table which is created. Yeah, that one is fine. So now we have only one route table associated with our VPC. So and we have two subnets, and we added the two sets to subnet associator. Now we need to create some routes for the internet gateway, right? Hmm. Now go to the internet gateway, select our gateway and check the details. What is, for suppose our ID, internet gateway ID, copy it, 70251. Then go to route tables and select our route table, and here routes, edit route, right? So I'm editing the routes. So I will not touch the default route, right? If you remove this route, you will be not able to communicate within your VPC. I will add route. So here I'm trying to connect through internet. So to find the from internet we are connecting. So we are giving all source points. So everyone who is connecting from internet should use this route and target internet gateway, right? So we can can only, as I said, we can only attach one internet gateway. So we have only one internet gateway attached to this VPC that will be showed here, and we can select that internet gateway, and you can save route, right? You can close it. So what we have done here is we created a IGW, we created a route table, and by default there is one route which is within the PC, within the VPC communication. Okay, so and route 2 which we added from the internet gateway. So what it is telling, so whenever the request comes to IGW from this VPC, take this route and we need to add which subnet. So we already added the routes in the subnet. So let's see what other configurations we can. So we added this route, so it will take the request from internet gateway, right? So whenever it is taking a request from internet gateway, that means it is getting request to one of the resource in this particular VPC, right? Understood? Associations. Right. Let's say let's connect to the VM, and then we can discuss what is happening here. So we will go to putty, and we will give our IP. This is my IP and putty and SSH. We need to give the ppk file every time. Sorry, ppk file every time unless you save that. Okay.ppk. Open. See, now we are trying. We are able to connect to that instance. Okay, but by default, our instance has a EC2. Our username is what is our username? I forgot my username is EC2 hyphen user. Sorry, EC2 hyphen user is a default username. I'm able to establish the communication, right? Because this is because we are able to successfully establish this network. So what it is, so here our request is going through the routing and it is able to connect to my EC2 instance, right? This is what we achieved. Let's say one more thing about subnet associations. So here, if you didn't understand subnet associations, um, I will tell you one more thing about this. So here, let's say I go to the subnet associations. There is subnets, route table, right? Route table, select my route table and subnet associations. Edit my subnet associations. Try to remove the subnet which created the um, uh, which we created which we created the instance. So subnet one is the one which we created and remove subnets, right? I want to remove subnet. This one, I remove this one. So we have this one and we removed the other one, right? That means we remove subnet in which we created the EC2 instance, right? Okay. Now try to connect to the putty, right? This one is already established. We can launch a duplicate association here. Okay, because there is no there is no okay. Let's say association IP. Okay. So I guess it is using as a because we given a default whatever the VPC is, whenever the VPC is getting the IP, we should know actually. Let's check. Okay, because it is default route table, it is connecting to it. Um, how can we do that now? Uh, we deleted the default route table. What happens is default route table will allows you to connect to all the subnets. So if we didn't deleted the default route table, then we can now add the VPC. Let's say we close it here We can discuss about our subnet associations more in detail later on, because we will launch more more subnets and more routings after. Then we can discuss what happens if the subnet associations not declared in um, our route. Yeah, I will end this here. We are now able to establish uh, connection successfully from our put via internet gateway route table, and we are able to connect to that each instance. I'll end it here.